Welcome, students, to another Webquest with Mr. Swan. What we have for you today is a Webquest, so not too many notes to go through, and hopefully you will enjoy it. And this video won't take too long because I'll just talk about picture of the day, at least in the beginning part. And then, so let's get right to it. Robot selfies for science. One of the first things that NASA does when it lands these landers on different planets is to try to take a picture of the actual lander itself. And they kind of released like a collection of them. And this actually went back for even more landers than actually I was able to fill up in this slide. And it's not just really just one picture that they take. Sometimes it's a collection of 57, like the Curiosity rover in the bottom left-hand corner. That was a collection of 57 photos to take one photo of itself. And the reason for them to take these pictures is to see if anything's broken. Anything's damaged, anything that got cracked on the way when it landed, or maybe there's like too much dust on the solar panels. And so this is how they figure out like if there's any types of problems, is by taking these robot selfies. And so for a while they've been doing that because Mars conditions are pretty harsh. As we talked about way back in the beginning of the year, I think Unit 1 in particular, these places have very little liquid water. So, and now we've just kind of finished up the atmosphere, so there's no atmosphere, so there's no real weathering and erosion of rocks with water, which helps to round out rocks. So instead, you get these things called the venifact rocks, which have been carved out by wind and are incredibly sharp. They're like tiny, like little blades on the ground, which then will damage the machine when it drives over them, such as it will slash up the tires. That becomes a big issue when you can't get over there to change them, because it's a 6-month trip, and humans probably wouldn't survive them the whole way. And so they kind of look at these things, they take these pictures, and that's how they figure out where to go. So sometimes these paths of these rovers don't really look like a straight line. They kind of look like this zigzaggy kind of roundabout line. Is that a lot of times they're dodging those really sharp things or things that could actually damage the machine, and by pictures is the way they tell us. So why this is all coming up is because they're really getting ready to launch the next one. And I have a little bit of info right towards the bottom of the slide about it. The Perseverance is now going to go up between July 17th and August 5th. That is going to be its launch date, and it looks like that's still going to happen. So something to look forward to over the summer. And then it will land there sometime in about like February-ish of 2021. So that'll be some new slides of the day for me when that happens. And they have other landers in there. The one in the bottom right, that's the one from this past year that I showed you at least a little bit. Martian climate lander looks very similar. That same kind of solar panel design, which is pretty neat. And as you might notice, in the middle of that picture on the top right, there's like a black kind of like hole in that picture. That's pretty much like where the camera was when it was like moving around taking photos, and then they stitched them all together to kind of get one of these. So can you take like one really good photo of the machine by itself? No, not really. There's the camera's connected by an arm, and then it's not far enough away. So that becomes mostly the bigger issue. So that's my picture of the day for you, a little celebration of some of our different machines that we send out in outer space. And now I'm going to move you guys on to your Webquest, which is right here. So your Webquest for you. This is the idea is to kind of go around and read about some of the different articles that I kind of liked. The first one is it talks about how people try to figure out how do ocean currents move. After that, it goes into this what they call the ship drift model, and they're trying to figure out how things will go adrift into the ocean. After that is this place called the earthnullschool.net, and the idea is to try to visualize what wind and ocean currents look like based on the data that we actually have, which is pretty neat. A little reading from NOAA, or NOAA.gov, about the global conveyor belt, which is neat, about how ocean currents carry the heat right around the world. And then finish it off with just a 2-minute YouTube video kind of showing that more of a nicer motion that visualizes how that conveyor belt moves comparatively to the article right above. So this is kind of the end of the video if you want it to be. I'm actually going to go read through this again into Webquest. I'm going to go and open up each website and kind of do like a little talk through about that, if you want like a little more of a deeper explanation. But your Webquest is to read it anyway, so if you wanted just to kind of pause and end it here, I'm totally okay with that as well, and you guys can jump right on over into that. So that choice will be yours. So if you want to stay, and you happen to stay, let's go right on through those websites. So the first one, this is what it looks like. This guy's name is Kurt. And what Kurt did and what he kind of became known for are these like little plastic animal toys that are showing right here on his arm. And what happened is that we had these ginormous cargo ships that go across the ocean, and sometimes things fall off of them. And so those big cargo containers fall off, and whatever's in kind of scatters around. And some of the most famous ones are Nike shoes. There's been one that was carrying hundreds/thousands of these Garfield telephones. I'm not making that up. And they wash on the shores of beaches over in France in particular. And they just, they kind of float around, and that happens. And so what people started to realize is that they wash up on the shore, and they didn't wash up on the shore every year, but they started to wash up on the shore in these patterns. And so that is what he's talking about. They actually have a little video in here as well. I'm not sure if it's going to play for you on your Chromebooks. But his idea of that, he met people along this coastline, and some of them actually recorded all the times and all the days they picked up the toys, what toys they picked up, what day they picked it up, and where they were located. And they had these journals, and that was actually fantastic science data. And they were able to take that data and start to prove that the ocean in these parts, prove that in these parts of the ocean, that it spins around. And then how long does that spin actually take? And they call that a gyre. So that's Gyre. And they were able to kind of figure out, how many years does that take? And so they kind of estimated it out to be about 4-ish. So that's what they're kind of talking about when they're kind of bringing up these things kind of falling over and people kind of scouring the beaches. And it wasn't just one person. This is what they call a citizen science project. This is thousands of people that kind of came and helped him out. From that, you go on now to the second website, which is this one. This is the ship drift model. And so what the idea is that depending on the month, and you can change the month down here from anywhere that you want, but I'll just pick May just because. And you can move your cursor over the map, and you can pick a latitude and longitude, and it's like you're dropping something into the ocean. So if you were to go here off of New York City and drop something in the ocean, you click it, and a new window pops up, and usually you have to open it. And I clicked right here on this black kind of diamond-ish X spot. And then it has these different pathways according to the different kind of speeds that it's actually going in different possibilities. So it's kind of if you drop something in right off the coast of New York, where would it go? And this sometimes based on the speed that's actually going, it can be caught in the northern Atlantic gyre. You can actually see these are on page 4, page 5 of your reference table. And other times it might have spin out. It might actually eventually go on over to the beaches over in this is Spain, and the possibility maybe traveling a little bit over into the northern Arctic. And then if you clicked on other spots such as this one, which I really like, actually let me click a little bit closer to land, about right there. Yeah. So this is over in the Indian Ocean. And if you drop an object to the west of Indonesia, right, it's where is it probably going to go? And it can a variety of places. And this is, if you kind of remember, there was an airliner that crashed a long time ago and it kind of went missing. Is that we use these for those kind of things? And then one of them, they thought it crashed over here. They thought it crashed over in this range, and so they were scouring all the way through all these islands, so I kind of looked for aircraft pieces, and they couldn't find it. They couldn't find anything, and all of these countries tried to go and help, and they couldn't find anything. And it turned out it did not really crash there. It crashed over here, into here, and by then, when they kind of really figured that out, weeks had gone by. It became a really big story for sure. And they didn't think they were going to find the pieces anymore because too much time had gone by. The ocean then carries these objects around. And they said, in months from now, it will probably wash up on the eastern coast of Africa. And sure enough, pieces of it actually started to do so. And so so those models actually work pretty well for that. But this is what these models are actually about, and to give you an idea of actually how it goes. So there's a little bit of description. There's a little bit of instructions on the bottom. And the main goal for this one, at least for your sheet, it's a little bit of latitude, longitude practice. So remember the equator's right here, right in the middle. And then if you go north above that, it's positive numbers, so between 0 and 90. And if you go south of that, any in this range, that's between what they call negative 90 all the way to 0. So that would just be like, we just use north and south, but you can use positive and negative if you want as well. And then your prime meridian, remember, is not located here. It's located all the way over here, right? So anything to the west of that, the numbers will go negative all the way to 180. And then to the east of that, it hits here, and then wraps right around over to here, and then continues to get to the 180. So a tinge of latitude, longitude review for you on that one. And then we move on. Earth null is this one. It's a really neat looking map. It might take a little while for it to load on your Chromebooks. It's totally worth the wait. This kind of shows different wind patterns that are kind of moving around. You can actually see the low pressure centers and how the wind's actually moving in these. And you can see that kind of that clockwise kind of movement. Or sorry, counterclockwise movement. There's lots of options. If you click down here on the bottom left where it says Earth, this is the air mode. You can do ocean as well, and it's just showing like the different waves and how the different waves are kind of moving right around and like where they're meeting, where they're actually kind of hitting the continents, right? I like the current ones quite a bit. And you click up here where it says Earth, and this will go away. And we talked a little bit last class about that current that goes right along the eastern coast of America, right? So like Gulf current, and it works its way and kind of like spreads out that heat up over into Europe, and it kind of gives you a nice show of that. You can drag this around to kind of see like different currents as they're kind of moving right around. Gives you a good idea when we were talking about like at least a little bit of like the El Nino, or like how that wind is kind of pushing that warm water to the west. It kind of builds up that heat over into there, and you can kind of see the remnants of that on this. There's tons of more options from these. You can actually look at like particulate matter. So like where is there more particulate matter like into the air, such as like some of these spots like over in here, that's a lot of dust in particular. Has like some like parts about like different types of chemicals you can actually go and find, versus like one in America. You can actually kind of zoom in if you want. Let me move this one down a little bit. Right, so like different hubs of some chemical pollutants, and if you look all the way over here, you can actually see some of the big hubs of those chemical pollutants over into China. So this one's a pretty neat one. I did not put any questions for you on this one. I felt this one was just a really fun thing to just go look at, because you don't really see like, I don't know, weather visualized like this so nicely. Which is a pretty cool thing to do. The faster the lines, or the faster the wind, the stronger, kind of longer the lines. Things that are like lighter, where it's not really, wind's not moving very much at all, you kind of see these ones. And you'll see like those high and low pressure centers. Let me go find one for you. Right, so you see this counterclockwise movement of the wind right here. So that would have to be a low pressure center. Another counterclockwise, low pressure center, another counterclockwise, low pressure center, and up here's a clockwise one. So it would be a high pressure center moving right on through. Pretty neat. I just like this map. Totally worth the watch. Next one is a small little article. It's very, very short. It's just a couple of these paragraphs. The questions go, I'm pretty sure I went through and I double checked this. They should go in order. So the first answer would be like right up in here. It's like what drives the ocean currents? Well, the winds at the surface do. And then it goes into more questions, and then you just go to number 2 and to number 3 eventually afterwards, and talks like a little bit about it. But it's really talking about, and then you answer the questions. I think that's pretty straightforward. I think you'll be fine on that. The global conveyor belt is really what they're talking about. Like, how does this water move right around? Because we know that cold sinks and warm rises. So how does that water move its way all the way around the Earth? And like, how is it bringing temperature around? Actually is quite well connected. And so that's what this video is. Another name for the ocean conveyor belt, the thermohaline. So that's like temperature, and like haline, like halite is like salt. Moves right around. And then this video is just showing some of that movement of like major, I should say the most important, the fastest, the strongest surface ocean currents. So kind of moving right around, like this one that we just talked about, the Gulf Coast current, and bringing like that warm water from the equator all the way up over into the poles. And then eventually, the water's going to get colder. It's going to get more dense, and as it get more dense, then it will eventually start to work its way down and sink. And so that's what these other lines here, and this is showing like the sea floor, this kind of rocky sea floor. And then those currents go on up, and then they go back down, and then they start moving their way back right around. And it kind of shows like a little bit of like land. So I'm gonna pause it real quick. Like there's Iceland, there's Greenland. I always kind of bring this up, and I always like to mention: does land float on water? Like, do islands float in the ocean? And they do not. They have a base of support of rock that goes all the way down to the bottom of the seafloor and rises all the way up. So what we see is just where the water couldn't reach and couldn't cover. And so this video is also pretty short, 2 minutes and 46 seconds long, and then you'll be all set on that, and just a few questions on that. So hopefully you have a nice time with this, kind of going around talking about some ocean currents, and we'll pick up at least a little bit on this, and I'll talk about some more things about this next time, which will be on Friday, and that's it for today. So hopefully you guys are having a nice April Fool's Day, and you'll have a nice midweek, and I'll talk to you next time. See you later.